Hello students, good morning. Um, in the previous class we have completed module number 2. So now from today onwards we shall start module number 3. So module number 3 is shear force and bending moments for beams. Okay. Uh, Here one thing you need to understand first. Uh, These shear force and bending moment diagrams are drawn for only for beams. Okay. So next, other thing, what you need to understand here is we have a beam. So there we have some support, and we will be having some loading for this. See, this chapter is very important. I want all of you to concentrate more here. Okay. Here. We have a beam and it is under loading. When we have a beam under loading, see what will happen to the beam. So this beam will show some reaction because of the external loading. So when the beam shows the reaction to the external loading, for this example, if I have this type of loading, your beam would deflect like this. You can understand. So your beam would deflect like this. So while undergoing this type of deflection, I'll draw more neatly here. So this is the beam. I hope you all understand what is beam is. So this is how a beam will be. When I apply some load, observe. This is the basic concept what you should be understanding. When I apply this load, your beam would bend like this. Okay. So it would bend like this. So this bending, we call it as deflection of the beam. Okay. We call this as the deflection of the beam. While undergoing this type of bending, you can observe the topmost layer here is compressed. So topmost layer is compressed and the bottommost layer is stretched. So when I say for example, if I have this as the beam, if I bend it, so topmost portion will compress, will get compression. The bottommost layer, that means to this side, this will experience some extension. So to understand this, when I cut this material, so at the cross section, uh, I shall take yes, see here if I have a beam like this one, and it is going to uh, bend like this. Thickness is very So when I cut this portion, you can observe when I cut this at this point, when I cut at this point, you will observe compression and tension at the bottom. Okay. Uh, say here, that cut portion I will take the cross section of that cut portion. Observe this. So I have this type of cut portion. and dragging everything. So I'll draw like this. Imagine this is the cut portion. So here, as I have told, at the top it will experience compression, and at the bottom it will experience tension force. So compression force andre hege andre, so in this portion, so almost on the upper half portion you will experience compression. ಏನಾಗ್ತಾ ಇದೆ, compressive force ಬರ್ತಾ ಇದೆ, compressive force. Okay, at the bottom fiber, you can observe tensile force ಅಂದ್ರೆ force which is coming out of the member earth, like this. So when a cross section is experiencing some force to be pushing and some force to be pulling, what will happen? This cross section will tend to rotate like this. If you can understand this concept, a simple concept. So at the top portion it is giving compression, and at the bottom portion it is experiencing extension. So that means pulling force. So also the action is like this here. So action is like this. The cross section or the beam tend to rotate at this point. At this section it is trying to rotate. So some portion is experiencing compression and some portion is experiencing tension. Because of this effect, the beam is experiencing the rotation. So this rotation we call it as bending moment. Okay. Bending moment. So this type we call it as bending moment. To understand the shear force now, so your shear force, if I take the same cross section like this, so your because we have applied one vertical force here which is acting downwards with respect to this reaction. So to produce the reaction for this action, there will be one vertical force on this surface. So ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, we will be having one vertical force like this. So ಇದೆಲ್ಲಿರುತ್ತೆ, ಈ section ಅಲ್ಲಿರುತ್ತೆ. We will be experiencing a vertical force at the cross section. So this force is called as shear force. So this is shear force. The force which is acting perpendicular to the cross section is the axial forces, compression and tension, with result to that, since the upper half portion is experiencing compression and lower half portion is experiencing tension, so it is causing the cross section to rotate. So that is why a bending moment is created. This is not just moment, this is called as bending moment. So we will experience bending moment. Because of the force which is acting downwards, there will be a shearing action like this. So a beam will experience, because of the loading, like this shearing action, like this one shearing action will takes place. Because of this shearing action, uh, this is the shearing action. So this at each and every cross section we will experience this type of force. We call this type of force as shear force. So in this chapter, uh, we will be noting that uh, we will be drawing the shear force and bending moment diagrams. What is this diagram is all about? This diagram will indicate the behavior of the beam. So how it is going to behave under shear force and how it is going to behave in bending. So usually, you might have understood the concepts of trusses. So in that, in your first year, you might have seen the problems on analysis of trusses. In that, one single member, it will either experience compression or tension. It will not experience bending. But here, in beams, we will experience bending. So you will experience bending, and most probably you, in most of the cases, you won't experience any axial forces. ಸೊ ಕಂಪ್ರೆಷನ್ ಬೆಂಡಿಂಗ್, ಕಂಪ್ರೆಷನ್ ಟೆನ್ಷನ್ ಫೋರ್ಸ್ ಅಂತ ಇರಲ್ಲ, ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇರುತ್ತೆ, ಬೆಂಡಿಂಗ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ದಿಸ್ ಟೈಪ್, ದಿಸ್ ಕಂಡೀಷನ್ ಆರ್ ದ ಬೆಂಡಿಂಗ್, ಇನ್ನೊಂದು ಹೆಸರಲ್ಲಿ ಹೇಳ್ಬೇಕಂದ್ರೆ ವಿ ಕಾಲ್ ದಿಸ್ ಬೆಂಡಿಂಗ್ ಆಸ್ ಫ್ಲೆಕ್ಷರ್. We call this as flexural members. Whenever in a question, if they ask, if they speak about flexural members, that means they are speaking about beams. So beams andre flexural members anta helbodu directly. Why it is called as flexural members? It is undergoing some flexure. Flexure is nothing but bending. So bending el place agutte, those types of member will be called as flexural members. So these are some basics for understanding the shear force and bending moment diagrams in this chapter. Um, Hope at this point of time it is clear for you. See, in this example, you can observe here, uh, we have a beam, simply supported beam, and it is of span having L, and it is under UDL loading, uniformly distributed load. At this point of time, I believe you will be able to understand the type of loadings. Mm, if at all you don't understand, I shall just brief you with that. See, this arrow mark kind of loading, we call this as point loading. Whenever there is some extra load which is distributed in some area, like this one. So throughout the length of the beam, we are experiencing some uniform load. Andre, this is nothing but small point loads which is acting at each and every point on the beam. So that type of loading we can call it as uniformly distributed load. Another type we can observe is uniformly varying one. So ಈ ತರ ಟ್ರಯಾಂಗುಲರ್ ಲೋಡಿಂಗ್ ನೋಡಿರ್ತೀರ. ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ರಿಯಾಕ್ಷನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರಲ್ಲ, ಅದೇ ಸೇಮ್ ಬೇಸಿಕ್ಸ್. Like this. So this is called as uniformly varying. So ಈ ರೀತಿ you might experience different types of loadings. So as I have mentioned earlier in the class, that if I have a cut section, I will see a shear force and a moment. So shear force is nothing but um, it is acting parallel to the cross section, and the moments are the one which is nothing but the unbalanced force. Okay, so unbalanced moment is equal to bending moment, and unbalanced force is equal to shear force. Now, while drawing the bending moment diagrams and the shear forces, we have to keep certain things in mind. That means sign convention is very, very important. Um, See, if I have like this, observe, uh, consider this as a beam and I am taking this as a section. When I am standing at this section, when I see an upward uh, facing load to the left of my beam, I will consider that as positive, as well as if I see a downward pointing load to the right side of the beam, I will consider that as a positive. Next, when I come to this beam, if I have a section like this, to the left of the beam, if I have a downward facing load, I will consider that as negative. If I have upward facing force to the right hand side, then I will consider that as negative. So you can even understand this concept by like this one. See here. Uh, so I have so I am fixed here. When I have a upward pointing load to the left of the beam, what will happen? This beam will tend to rotate clockwise. So that is why I am considering it as positive. Say, when I have a downward facing load to the right of the beam, so this is also causing what? Clockwise, rotation. So that is why I can understand this as positive. So vice versa, if I have, see here, if I have a downward facing load, if I have a downward facing load to the left, what will this do? So it will rotate the beam anti-clockwise. It will rotate the beam anti-clockwise. Okay. So uh, and whenever there is a force to the right which is acting upwards, so this will cause anti-clockwise moment. So which is negative. So this is negative. So this is the sign convention for shear force. Okay. Next, for bending moment, we have different type of uh, sign conventions. For shear, whenever a beam at the center, if it is going downwards, so like this, we call this as sagging. For sagging, the sign convention is positive. Whenever beam bends in reverse direction like this, we call this as hogging. We call this as hogging. Then the sign convention is negative. ಸೊ ಏನಕ್ಕೆ ಈ ಥರ ಆಗುತ್ತೆ ಅಂದರೆ ಲೆಫ್ಟ್ ಸೈಡು ಕ್ಲಾಕ್ ವೈಸು ರೈಟ್ ಸೈಡು ಆ್ಯಂಟಿ ಕ್ಲಾಕ್ ವೈಸು ಅಂತ ಅಂದರೆ ಏನು ಮಾಡ್ತಾ ಇದೆ ಏನು ಮಾಡ್ತಾ ಇದೆ ಈ ಬೀಮ್ನ ಹೀಗೆ ಬೆಂಡ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ಹೀಗೆ ರೊಟೇಟ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ಇಟ್ ಈಸ್ ಸ್ಯಾಗಿಂಗ್, ಇಟ್ ಈಸ್ ಪಾಸಿಟಿವ್. ಇನ್ನೊಂದು ಕೇಸಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದೆ, ಹೀಗೆ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ಹೀಗೆ ರೊಟೇಟ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ದಿಸ್ ಈಸ್ ನೆಗೆಟಿವ್. ಹೇಗಪ್ಪ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು ಸ್ಯಾಗಿಂಗ್ ಹಾಗಿಂಗ್ನ ಅಂತಂದರೆ ವೆರಿ ಸಿಂಪಲ್. ಸಿ ಸ್ಯಾಗಿಂಗ್ ಅಂದ್ರೇನು? ಹೀಗೆ. ಸೊ whenever you have a smiling face, you can call that as positive. Smiling ಅಂದ್ರೇನು? Positive. So sagging is positive. Okay. Hogging. So hogging ಹೇಗೆ ಕಾಣುತ್ತೆ? Hogging looks like a sad face. Sad face. Okay. Whenever you are sad, that means it is negative. Alva? So it is negative for you. So this is just a crude method to understand the concept. So if you have a smiling face, andre sagging ಆಗ್ತಾ ಇದ್ರೆ positive, hogging ಆಗ್ತಾ ಇದ್ರೆ negative. Don't get confused here. This is very simple. Whenever you have sagging bending moment, it is positive. Whenever you have hogging bending moment, it is negative. Okay. Hope it is understood. So we shall understand types of supports here. We have simple supports, roller support, hinged or pin supports, right? And fixed supports. So these are the four types of supports we have for a beam. Simple supports are very similar to your roller supports. ಏನಂದ್ರೆ ರೋಲಿಂಗ್ ಇರುವಾಗ ಏನಾಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಸಿಯರ್ ದಿಸ್ ರೋಲರ್ನ ಈ ಥರ ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೀವಿ. ಒಂದು ಟ್ರಯಾಂಗಲ್ ಬರೆದೋದಕ್ಕೆ ಕೆಳಗಡೆ ಚಕ್ರ ಕೊಡ್ತಿರ್ತೀವಿ. ಇದು ದಟ್ ಈಸ್ ಇಂಡಿಕೇಟೆಡ್ ಆಸ್ ರೋಲರ್ ಸಪೋರ್ಟ್. ಈ ರೋಲರ್ ಸಪೋರ್ಟ್ ಪ್ರೊವೈಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಈ ರೋಲರ್ ಸಪೋರ್ಟ್ ಇದ್ದಾಗ ಏನು ಮಾಡ್ಬೋದು ಅಂದರೆ ಹಿಯರ್ ಇಟ್ ವಿಲ್ ಬಿ ಪಿನ್ಡ್ ಇನ್ ನೇಚರ್. ಸೊ ಇಟ್ ಕ್ಯಾನ್ ರೊಟೇಟ್ ಲೈಕ್ ದಿಸ್. ಸೊ ಮೇಲೆ ಕೆಳಗೆ ರೊಟೇಟ್ ಆಗ್ಬೋದು. ಸೊ ರೋಲರ್ ಅಂದರೆ ಆ ಜಾಯಿಂಟಲ್ಲಿ ಪಿನ್ ಆಗಿರುತ್ತೆ. ಆ ಪಿನ್ ಆಗಿದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಇಟ್ ಈಸ್ ಏಬಲ್ ಟು ರೊಟೇಟ್. ಸೊ ದೇರ್ ಈಸ್ ನೋ ರಿಸ್ಟ್ರಿಕ್ಷನ್ ಫಾರ್ ರೊಟೇಷನ್ as well as there is no restriction for movement since it is having the wheels. So wheels ಇರೋದ್ರಿಂದ ಏನಾಗ್ತಾ ಇದೆ ಹಾರಿಜಾಂಟಲ್ ಮೂವ್ಮೆಂಟ್ ಮಾಡ್ಬೋದು ಈಸಿಯಾಗಿ. ಸೊ there is no restriction for horizontal movement and there is no restriction for rotation like this. It is rotating like this, so there is no restriction for that. Since there is no restriction for rotation and horizontal movement, there will be no reaction, but it is fixed at the bottom, so it cannot move vertically. Even it cannot move upward or it cannot move downwards. Since there is some restriction, that means there is some restricting force which is restricting the vertical forces. So vertical force ಏನು ಮಾಡ್ತಾ ಇದೆ, ವರ್ಟಿಕಲ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗಕ್ಕೆ ವರ್ಟಿಕಲಿ ಮೂವ್ಮೆಂಟ್ ಆಗಕ್ಕೆ ಬಿಡ್ತಾ ಇಲ್ಲ ಅದು. ಸೊ ಅದಕ್ಕೆ ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ, we are experiencing some restriction. So that restriction itself is because of that restriction there is some reaction developed. So reaction developed here. ಸೊ ಇಲ್ಲಿ ರೋಲರ್ ಸಪೋರ್ಟ್ಗೆ ಒಂದೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ಬರೋದು ಯಾವುದು, ವರ್ಟಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಅಷ್ಟೇ. ವರ್ಟಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಅನ್ನೋದಕ್ಕಿಂತ ದಿಸ್ ರಿಯಾಕ್ಷನ್ ವಿಲ್ ಬಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದಿ ರೋಲರ್ ಸಪೋರ್ಟ್. ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನಿಮ್ಮ ರೋಲರ್ ಸಪೋರ್ಟ್ ಈ ಥರ ಇನ್ಕ್ಲೈನ್ಡ್ ನೇಚರಲ್ಲಿ ಇತ್ತು ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಸೊ ಇನ್ಕ್ಲೈನ್ಡ್ ಆಗಿದ್ದರೆ ಸೊ ಅದಕ್ಕೆ ರಿಯಾಕ್ಷನ್ ಏನಾಗುತ್ತೆ, ಅದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ರಿಯಾಕ್ಷನ್ ಬರುತ್ತೆ. So this is the type of reaction which we'll experience in roller support. Okay. Next we have a hinged support or pin support. So here at the bottom it is not having any roller. So it is not able to move in horizontal direction. ಆಗ್ತಾ ಇಲ್ಲ, horizontal direction ಮೂವ್ ಆಗಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ಲ. ಮೇಲೆ ಕೆಳಗೆ ಮೂವ್ ಆಗಕ್ಕೆ ಆಗ್ತಾ ಇದೆಯಾ, ಆಗ್ತಾ ಇಲ್ಲ. But it can rotate. It can only rotate. So it can freely rotate, but there is restriction for horizontal movement and there is restriction for vertical movement. Whenever there is restriction for vertical movement, we will experience a vertical reaction. Whenever we experience horizontal restriction, we will resulting of which we will experience horizontal reaction. So for a pin support, we will have one horizontal reaction and one vertical reaction. Okay. For any restriction, there will be some reaction. So this is about the pin supports. Next we have fixed support. Here you can observe whenever some material is fixed like this. So when I try to rotate it, it is not rotating. When I try to move horizontally, it is not moving. When I try to move vertically, it is not moving. That means at the support it is just fixed. So there is no free movement in any direction. So there is a restriction for horizontal movement, then you will experience horizontal reaction. There is a restriction for vertical movement, then there is vertical reaction. And there is a restriction for rotation as well. Rotation go restriction ಇದೆ. Then you will experience what? Rotational reaction. So rotational reaction ಏನಂತೀವಿ ನಾವು ಮೂಮೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಫಿಕ್ಸೆಡ್ ಸಪೋರ್ಟ್ ಇದ್ರೆ ಮೂರು ರಿಯಾಕ್ಷನ್ ಬರುತ್ತೆ. ಯಾವುದು? ಒಂದು ವರ್ಟಿಕಲ್, ಒಂದು ಹಾರಿಜಾಂಟಲ್, ಮತ್ತೊಂದೇನು ರೊಟೇಷನ್. ಈ ರೊಟೇಷನ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರ್ಬೋದು, ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದಿ ಲೋಡಿಂಗ್ ಕಂಡೀಷನ್. ಓಕೆ, depending upon the loading condition. So this is how the reactions can be calculated for a given type of support. Okay, so these are the type of supports. So here with this knowledge of support reactions, we shall understand the types of beam present. Okay, so first one we have simply supported beam. A simply supported beam having, see here at the point A we have only pin joint. Pin joint ಗೆ reactions ಯಾವ್ದು? ಒಂದು vertical, ಇನ್ನೊಂದೇನು horizontal. Roller support ಗೆ ಎಷ್ಟು reaction? ಒಂದೇ reaction, perpendicular to the direction of the roller, ಅಂದ್ರೆ vertical reaction. So these are the reactions for this simply supported beam. ಸೊ ನೆಕ್ಸ್ಟ್ ಕಂಟಿನ್ಯೂಸ್ ಬೀಮ್ ಅಂದ್ರೆ 2 or more supports ಇದ್ರೆ, ಅಂದ್ರೆ if we have more than 2 supports for a beam, we consider that as continuous beam. ಕಂಟಿನ್ಯೂಸ್ ಬೀಮ್ ಅಂತಂದ್ರೇನು? ಎರಡಕ್ಕಿಂತ ಜಾಸ್ತಿ ಸಪೋರ್ಟ್ ಇದ್ರೆ ಅದನ್ನ ಕಂಟಿನ್ಯೂಸ್ ಬೀಮ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇನ್ನೊಂದು ತರ ಹೇಳ್ಬೇಕಂದ್ರೆ we have more than one span. ಸೊ ಒಂದು ಸ್ಪ್ಯಾನ್ಗಿಂತ ಹೆಚ್ಚಿಗೆ ಸ್ಪ್ಯಾನ್ ಇದ್ರೆ ಅದನ್ನ ಕಂಟಿನ್ಯೂಸ್ ಬೀಮ್ ಅಂತಾರೆ, ಇನ್ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಅದು. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಕಂಟಿನ್ಯೂಸ್ ಬೀಮ್. ಈ ಕಂಟಿನ್ಯೂಸ್ ಬೀಮ್ಗೆ ಹೇಗಪ್ಪ ಇದೆ ರಿಯಾಕ್ಷನ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಇದೇನು ಪಿನ್, ಒಂದು ವರ್ಟಿಕಲ್, ಒಂದು ಹಾರಿಜಾಂಟಲ್. ಇದೇನು ರೋಲರ್, ಒಂದು ವರ್ಟಿಕಲ್. ಇಲ್ಲಿ ಏನು ಪಿನ್, ತಿರ್ಗಾ ವರ್ಟಿಕಲ್, ಒಂದು ಹಾರಿಜಾಂಟಲ್. ಡೈರೆಕ್ಷನ್ ಯಾವ್ದಾದ್ರು ಆಗಿರ್ಬೋದು. ಓಕೆ, next type of beam we have is cantilever type. Cantilever ಅಂತಂದ್ರೇನು? Cantilever means at one end it will be fixed, at other edge it will be free. So one end ಅಲ್ಲಿ ಫಿಕ್ಸ್ ಆಗಿರುತ್ತೆ, ಇನ್ನೊಂದು ಎಂಡ್ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಫ್ರೀ ಆಗಿರುತ್ತೆ. This type of beam we call it as cantilever beam. So one side fix ಆಗಿರೋದ್ರಿಂದ what are all the types of reaction you will experience at this support? ಒಂದು ವರ್ಟಿಕಲ್, ಒಂದು ಹಾರಿಜಾಂಟಲ್, and another one is moment. So more type, 3 reactions we will experience. 3 types of reactions we will experience at fixed end. And there is no reaction at the free end. Don't get confused here. ಫಿಕ್ಸ್ ಆಗಿದ್ರೆ 3 ರಿಯಾಕ್ಷನ್ ಬರುತ್ತೆ. ಫ್ರೀ ಇದ್ರೆ ಎಲ್ಲ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೂ ಇಟ್ ಈಸ್ ಫ್ರೀ. ಸೊ ದೇರ್ ಇಸ್ ವರ್ಟಿಕಲ್ ಮೂವ್ಮೆಂಟ್ ಇದೆ, ಹಾರಿಜಾಂಟಲ್ ಮೂವ್ಮೆಂಟ್ ಇದೆ, ರೊಟೇಷನ್ ಇದೆ, ಎಲ್ಲ ಇದೆ. ಸೆನ್ಸ್ ದೇರ್ ಇಸ್ ನೋ ರಿಸ್ಟ್ರಿಕ್ಷನ್ ಫಾರ್ ದಟ್. ಸೊ ರಿಸ್ಟ್ರಿಕ್ಷನ್ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಏನಿಲ್ಲ, ರಿಯಾಕ್ಷನ್ಸ್ ಇರಲ್ಲ. ಸೊ ರಿಸ್ಟ್ರಿಕ್ಷನ್ ಇದ್ರೆ ರಿಯಾಕ್ಷನ್, ರಿಸ್ಟ್ರಿಕ್ಷನ್ ಇಲ್ಲ ಅಂದ್ರೆ ರಿಯಾಕ್ಷನ್ ಇಲ್ಲ. ಸೊ ರಿಸ್ಟ್ರಿಕ್ಷನ್ ಇಲ್ದೇ ಇರೋ ಕಂಡೀಷನ್ನ ಏನು ಹೇಳ್ತೀವಿ ನಾವು? ಡಿಗ್ರಿ ಆಫ್ ಫ್ರೀಡಮ್ ಅಂತ ಹೇಳ್ತೀವಿ. ರಿಸ್ಟ್ರಿಕ್ಷನ್ ಇರೋದಕ್ಕೆ ರಿಯಾಕ್ಷನ್ಸ್ ಬರುತ್ತೆ. ಸೊ ಡಿಗ್ರಿ ಆಫ್ ಫ್ರೀಡಮ್ಗೆಲ್ಲ ಹೋಗೋದು ಬೇಡ ಇವಾಗ, ಮುಂದಕ್ಕೆ ನೋಡೋಣ. ಇನ್ನು ಅದರ್ ಟೈಪ್ಸ್ ಆಫ್ ಬೀಮ್ಸ್ ವಿ ಶಾಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಸೊ ವಿ ಹ್ಯಾವ್ ಪ್ರಾಪ್ಡ್ ಕ್ಯಾಂಟಿಲಿವರ್ ಬೀಮ್. ಪ್ರಾಪ್ಡ್ ಕ್ಯಾಂಟಿಲಿವರ್ ಅಂತಂದ್ರೆ ಏನಿಲ್ಲ, ಒನ್ ಸೈಡ್ ಫಿಕ್ಸ್, ಅನದರ್ ಸೈಡ್ ಫ್ರೀ ಇದ್ರೆ ಏನಂತ ಕರಿತೀವಿ? ಅದಕ್ಕೆ ಕ್ಯಾಂಟಿಲಿವರ್ ಬೀಮ್ ಅಂತ ಕರಿತೀವಿ. ಈ ಫ್ರೀ ಎಂಡ್ಗೆ ಜಸ್ಟ್ ಸಿಂಪಲ್ ಸಪೋರ್ಟ್ ಕೊಟ್ಬಿಟ್ರೆ, ನಾನು ಸಿಂಪಲ್ ಸಪೋರ್ಟ್, ಜಸ್ಟ್ ಒಂದು ಸಪೋರ್ಟ್ ಕೊಟ್ಬಿಟ್ರೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪ್ರಾಪ್ಡ್ ಕ್ಯಾಂಟಿಲಿವರ್. ಸೊ ಐ ಆಮ್ ಪ್ರೊವೈಡಿಂಗ್ ಎ ಪ್ರಾಪ್. ಸೊ ಸುಮ್ಮನೆ ಫ್ರೀ ಆಗಿಬಿಡ್ತಲ್ಲ, ಸುಮ್ಮನೆ ಒಂದು ಪ್ರಾಪ್ ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪ್ರಾಪ್ಡ್ ಕ್ಯಾಂಟಿಲಿವರ್ ಬೀಮ್ ಅಷ್ಟೇ. So another one is overhang beam. Overhang beam, if we consider an overhang beam, so one edge will be having one support. So another support will not be at the edge of the beam, it will be at some distance. See here, ಈ distance ಅಲ್ಲಿ support ಇರುತ್ತೆ ಅನ್ಕೊಳ್ಳಿ. ಸೊ ಇಲ್ಲಿ ಸಪೋರ್ಟ್ ಇದೆ. ಸೊ ದೇರ್ ಇಸ್ ಸಮ್ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಪೋರ್ಷನ್. ಸೊ ಈ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಪೋರ್ಷನ್ನ ನಾವು ಕ್ಯಾಂಟಿಲಿವರ್ ಅಂತ ಏನು ಹೇಳೋಕ್ಕಾಗಲ್ಲ. ಸೊ ಕ್ಯಾಂಟಿಲಿವರ್ ಅಂದರೆ ಅದು ಒಂದು ಸೈಡ್ ಫಿಕ್ಸು ಮತ್ತು ಅನದರ್ ಫ್ರೀ ಇದ್ದರೆ ಮಾತ್ರ ಕ್ಯಾಂಟಿಲಿವರ್. ಇದೇನಾಗ್ತಾಯಿದೆ, ಸಿಂಪಲ್ ಸಪೋರ್ಟ್ ಮೇಲೆಯಿಂದ ಇನ್ನು ಪ್ರೊಜೆಕ್ಟ್ ಆಗಿದೆ, ಎಕ್ಸ್ಟ್ರಾ ಪ್ರೊಜೆಕ್ಷನ್ ಆಗಿದೆ, ಅಂದರೆ ಓವರ್ ಹ್ಯಾಂಗ್ ಆಗಿದೆ, ಓವರ್ಲಿ ಹ್ಯಾಂಗ್. ಸೊ ಓವರ್ ಹ್ಯಾಂಗ್ ಸಪೋರ್ಟ್, ಓವರ್ ಹ್ಯಾಂಗ್ ಬೀಮ್ ಅಂತ ಕರಿತೀವಿ ಇದನ್ನು. ಓಕೆ, ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಓವರ್ ಹ್ಯಾಂಗ್ ಬೀಮ್. Next we shall see what are the types of loads. Loads ನಾನು ಅವಾಗಲೇ ಹೇಳಿದೆ, ಪಾಯಿಂಟ್ ಲೋಡ್ಸು. ಸೊ ಇಲ್ಲಿ 6 ಕಿಲೋಮೀಟರ್, 2 ಕಿಲೋಮೀಟರ್, 5 ಕಿಲೋಮೀಟರ್ ಅನ್ನೋದೆಲ್ಲ ಏನು ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಲೋಡ್ ಅಥವಾ ಪಾಯಿಂಟ್ ಲೋಡ್ ಅಂತ ಕರಿತೀವಿ. ನೆಕ್ಸ್ಟ್ UDL, ಯೂನಿಫಾರ್ಮ್ಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಲೋಡ್, 20 ಕಿಲೋಮೀಟರ್ ಪರ್ ಮೀಟರ್. ಸೊ ಫುಲ್ ಲೆಂತ್ಗೂ ಇರ್ಬೋದು, ಹಾಫ್ ಲೆಂತ್ಗೂ ಇರ್ಬೋದು, ಅಥವಾ ಸಮ್ವೇರ್ ಇನ್ ಬಿಟ್ವೀನ್ ರ್ಯಾಂಡಮ್ ಆಗಿರ್ಬೋದು. ಅದನ್ನು ಏನಂತೀವಿ, ಯೂನಿಫಾರ್ಮ್ಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಲೋಡ್ ಅಂತ ಕರಿತೀವಿ. ಯೂನಿಫಾರ್ಮ್ಲಿ ವೇರಿಯಿಂಗ್ ಲೋಡ್ ನೋಡಿ. ಸೊ ಈ ಯೂನಿಫಾರ್ಮ್ಲಿ ವೇರಿಯಿಂಗ್ ಲೋಡ್ನ ವಿ ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ಬ್ಯಾಕ್ ಟು ಪಾಯಿಂಟ್ ಲೋಡ್, ಅಂದರೆ ಪಾಯಿಂಟ್ ಲೋಡಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಬೋದು. ಸೊ ಯೂನಿಫಾರ್ಮ್ಲಿ ವೇರಿಯಿಂಗ್ ಟ್ರಯಾಂಗುಲರ್ ಲೋಡ್, ಈ ಥರ ಲೋಡ್ ಇದ್ರು. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ in the next class I believe we will be understanding the reaction forces, how to calculate the reactions. With the help of those reaction, then only we will be able to calculate the shear forces and bending moment for the beams. Okay, so I believe you should be very proactive during the next class, so that you should keep your book and pen handy. That means you have to draw the shear force and bending moments along with me. Okay, so there is no excuse. Okay, so at this point of time I shall end the session here, today's session. From tomorrow I'll be explaining the shear, how we shall see how to draw bending moment and shear force diagrams. Today we have understood what is beam, how it behaves, and what is the bending moment and what is the shear force. And from tomorrow onwards we shall do some calculations, derivations and all. Okay. Thank you.